Hey folks, it's George Leoniak and welcome to New Geometry. Today we're going to do something a little different. It's been a little while since I've done a drawing video, and today we're going to focus on this Easter Sunday, the resurrection of the dodecahedron. So I've got a nice little drawing, super simple and easy, probably the most simplest method to draw a dodecahedron that you'll probably ever find. That will be 100% accurate dodecahedron in the drawing. So join me for this pretty short video. I'm going to switch over to the iPad here. And this is one I think that, if you're new to even drawing sacred geometry, you'll be able to follow along pretty easily if you have a compass, a straight edge, and a pencil. You'll be fine with following along here. Just takes a minute to set a couple seconds here, or maybe a minute to switch over. So yes, this is going to work on the accurate version of the dodecahedron, as many of you might know from seeing some of my other videos. As I pointed out, the dodecahedron, as it's been represented in the Metatron's cube, is a lot of circles and lines, which is more, in the end, kind of an artistic representation of the dodecahedron, in that the 5 proportions are not maintained within that. So we've got a very simple method that's really going to only call upon, I believe, 13 circles. And all the lines you'll have to do are pretty much going to be to make the dodecahedron. So in your drawing pad here, we're going to lay out either a horizontal or vertical line. At some point, we're going to orient that line. So in the center of your page, a little lengthwise, try to locate the center, because we're first circle we're going to do along that vertical line. I'm not going to label all the points. This is just kind of almost like a little bit of a sampling of what I do in my Patreon and my apprenticeship programs, just many drawings that we've been doing. And this was one that I actually did a drawing with the apprentices earlier this session. So we've got our first circle down, and we're going to do this drawing from the hexagon perspective with the seed of life. So very simply, we're going to do the classic drawing of just going around, and every point where that circle intersects the central circle, which I'll color blue in a second, we're going to continue on all the way around, and that will produce the 6 circles on the circumference of our central circle, which is now blue. Let's make it a little bit thinner line of blue. Okay, so now, like I said, this is going to be simple method for us. So what we'll do now is lay out the rest of the lines. We're actually going to put down 6 lines of symmetry here, but let's lay down 3 of those lines by starting in the upper right petal, laying out your ruler, and you could stop at the end of the distal circles, but I want you to just send a line all the way through, just like that. And you can do one through the other set of petals, upper left. So we have our 6 directions there, or the 3 lines on the paper. Next step is in the little valleys, there's another petal. It is off of this vesica here. So we're going to run a line all the way through that vesica and continuing all the way through, just like so. And we're going to do that for all the vesicas there, right? So we have 6 lines of symmetry. We have basically divided 12 segments quite easily just by drawing the seed of life. You can draw in the other 6 circles if you like, but there's really not any real reason to do that for this drawing. So here's the most important part of this drawing, and this is really all you're going to need to do. We're going to now have to change our compass radius. And in my other videos, I talk about the golden circle seed of life, where I put 5 ratio circles in it. in each of these circles, and I have a technique of how I like to go about this, but this one is called the invisible golden circles diagram, because the golden circles are going to be invisible. So I thought for this Easter, it'd be like you can almost go on like an Easter egg hunt to find out where these invisible golden circles will be. But how we're going to do this, instead of doing that, is plant your compass up over at the vertical line that we had at the top portion. And we're going to set your compass radius. Let me just label these points. That will be helpful for you. A to B. Once you set up your compass radius from A to B, you're good to go, because what we want to do is draw circles basically on each of the 6 petal tips, the small little petals, 6 of those. With that radius, we're going to draw circles all the way around those 6. So here's A to B. Okay, now we're going to go from here down to here, going across once again on the petal tips, always going and returning to the petal tips, basically leapfrogging over 2. And the last one, oh, I skipped one. There we go. And now we have that pattern. And that's the invisible golden circles, because you might not realize it, right, just glancing at that, but you've produced the phi ratio within that pattern in design. Let me get rid of the labels. Typically, when I do my drawings with the group, I do a lot of labeling, but I want to give you something with not so many letters on it, so you could just kind of be with the image itself. So the next thing we're going to do, you don't actually need to do this, but I need to lay out a hexagon in this petal arrangement, the 6 inner petals. So I'm going to just lay out a hexagon, and you can draw a hexagon by connecting those petals together. And let me get rid of that letter again. So like I said, you don't need to do that, but what we're going to do now is we're going to draw in the dodecahedron external hull of what it looks like from this perspective. So we're going to draw the outer shape of the dodecahedron, and I'll change to a thick black color here. And this is the key point. So if you are just focused on this petal right over here between the 2 petals, but this larger one that we subdivided in half here, you see there was this little section here. Let's first actually, every little nipped petal that you see here by that hexagon that I did, you can lay your ruler out if you want from between these 2 points, but we're going to draw segments. So you can lay out a ruler there. We're going to draw another segment here. And every one of those nipped little tops of the petals, we just are drawing in these segments just like so. So just go around your paper and just fill those in. And the next step is, once those are done, we're going to now just connect those small little segments together at the distal ends of the petals, just like this. Like I said, this is going to probably be the most simple method to create a dodecahedron that you can find that is very simple to do and 100% accurate, and I'll show you all the reasons why in just a little bit. Okay, so the next step is, let's go to the center of our circle, and let's extend a line over. There's this very cool 6-pointed happy star. It's kind of a filled up version of the typical 6-pointed triangles. So let's draw a line up over to that first little node point right there where those 2 circles cross. Now remember, these are the larger circles that we put in. And we're gonna do the same thing to the bottom right and the bottom left. So that could be an equilateral triangle, but remember, this is if I connected those. But remember, this is kind of a little puffed up, happy 6-pointed star. So we are going to now just connect 1, 2, 3, 4, 5, 6 more lines, and then you will have done the dodecahedron drawing. It's been resurrected from the Metatron's cube version invoke the ether into its rightful phi ratio relationship for this form. So let's connect this point from the center. Let's focus on this point right here at the top of the little 6-pointed happy star. I'm going to connect that over to this lower portion of that little segment that we did on the left side here. And we're going to do the same thing on the right. And we're going to do that down in the bottom right here. We're going to connect that over there and over there. So we have these outer segments. And this is what, Metatron's cube tried to find those little segments just like that in the drawing, but didn't come up with the right location to accurately create the phi ratio between this edge and this edge. And let's just do a thin red line so you could see that edge, because we're about to compare that edge, this edge of the star, to that edge, because we want to transfer the pentagon to a new view. And we want it to fit. So the relationship of the back edge to this long edge is what is proportional in the phi ratio in the pentagon, phi ratio in that. Okay, so we just did also some amazing sacred geometry within this. So I have just to the left of our drawing, and you might say, wow, that was it? That's all it took to draw the dodecahedron? Yes, that is. You could draw the back of it, because we have 1, 2, 3, 4, 5, 6 sides of the pentagonal faced dodecahedron, and the other 6 would be on the back. You're just going to basically reverse the central lines here. The outer hull will, of course, stay the same. And then just draw it in as a dotted line pattern. It's easy to do. In fact, let's just do that. So we're going to extend lines out like this, the dotted red lines. And then now we're just going to reverse those connection points on the other side. And then it will be like we're looking through the form to the back side like that. So let's check out just a few things that I've prepared on the side here, just to show the sacred geometry that is contained within this. Let's get rid of that long line that's going through there. So let's say that my hexagon edge, and I'll make that a red solid line. If that were a 1-inch hexagon edge, I know I'm going to cut off a portion of my dodecahedron. That line is the same length of this 1-inch square, okay? So if that's a 1-inch square, let's just double check my measurements quickly. So if just to show you that this is the same length, those two light up blue telling me that they are the same. So that's 1 inch. Then this distance of, so this is a 1-inch radius circle, right? So these are 2-inch diameter circles that we did our seed of life with, okay? So you could actually draw your drawing with a 1-inch radius, and you'll have 2-inch diameter circles. The next thing I want to show is that root 2, this red line, right? So whenever you have a square and you divide that in half along the diagonal here, right, into these two triangles, that's called root 2, 1.414, an irrational number that is the diagonal of the square. So that measurement happens to be this measurement of the second circle that we did. So our first circle was this measurement. Let's do that in black. I'll extend it out over here. This was 1 inch. The other is root 2, but let's just double check that, because how does it, this looks a little longer to me. It doesn't look the same. So let's make sure. Now, root 2 is essential to the cube for sure. So we are using root 2 in our construction of the dodecahedron here. So let's drag that and check, and both of those light up blue. So we've got that as well. And of course, we have a lot of vesicas in that. And if this were a cube, just like this cube, so here's the line going across, here's the 1-inch edge. If I turn the cube this way, from this vertice that's opposing the other vertice, like we like to look at the Merkaba spinning like this, well, then that diagonal from internal diagonal of this cube, that is the √3 measurement. So that's 1.732 ... So let's just see where our √3 measurement had shown up in the drawing. So that's going to be these vesicas that we started out with. Let's do that in blue. Oh, I tried to draw it on the wrong screen. Let's go over here. So that's our √3 measurement. So far we got 1 inch, we got the √2 or 1, √2, and √3. Let's just see, that should be 3 of our most sacred roots are contained within this dodecahedron drawing. But now the big question must be on your mind, well, wait a second, okay, we've got those measurements, that's pretty cool, but what about the pentagon face of the dodecahedron? This was not just about the cube measurements and the sacred geometry of the sacred roots that are supposed to be in this. So here we're going to, I've constructed a pentagon here, and remember I had a red line that's going to, oh, let's do that red. Got a red line that is this star, basically, right? So this is the pentagon star. Remember, each of those are a portion of a cube, or, and as I'm learning, it could be quite a number of things, like icosahedron edges or dodecahedron edges, or so many other possibilities, icosahedron. But we want to now test that out, right? Because let's test to make sure that my back edge of the drawing is the same as this edge right here. So let's see if these light up in blue. I hope they do, and I didn't make any errors in the drawing. That does happen sometimes if a little spot gets out of place, but let's just check it out. That lights up in blue. Let me see if I can move the screen over. I think I'm blocking it. Let's do it one more time for you. So we've got that, and we have that. Okay, so we know that those are in proportion to one another. Well, you know, they're equal in length. So let's just now check our star. So this is really the moment of truth to see if we've done a kind of orthogonal projection of this, where the flat version would be projected onto the of this pentagon here, would be projected into this angled version here. So we got to check the star length, right? So I'm taking the measurement over there, and I'm taking the measurement from that point there. I have to do this carefully. And if that lights up, which it does, then we are good. See how it did it? It did it there, and it will also do it along this edge of the, let's do another line so you see where I'm pointing to here. Let's do this section, right? So that could be another pentagon star face there. So let's take that measurement to just see if this maintains its truth throughout the form. So if I grab from there and once again check the star length, we have another match. So this is our resurrected dodecahedron, evoking the ether, and I'll show you why it's evoking the ether, because once we are able to correctly draw this dodecahedron, which there are not many examples of it out there actually, because of the version that we've been given or presented to us for quite a long time, hasn't been doing this accurate rendering, and all the Wikipedia and of course all the computer programs that have come out, but the humble geometers out there who have been drawing away with their compasses and rulers for hundreds, if not thousands of years, have been using something that wasn't working in many cases. So now we have a quite simple way, and remember, this is the invisible golden circles because this is your Easter egg hunt, is to discover where the rest of the golden circles are in here. There's 7 more and another layer of 7, and many, many more within this basic template here that's based on root 2. So this is why, as I was alluding to, once we're able to go through the process of correcting the dodecahedron there, then we're able to do magnificent constructions utilizing the dodecahedron within sacred geometry and uniting, in this case here, 12 dodecahedron are all in phi proportion, not just in the pentagonal perspective that we can draw the dodecahedron, but now we're looking at it from this flower of life view and infused with all the golden circles, so many Easter eggs in this one. And this is now a 12 around 1 situation, a Kasi dodecahedron in the middle of this. And my next video after this one is going to be all about this structure and how it stellates with the icosahedron that's also woven in this. And this relates to my previous video called the Golden Matrix of Infinity, PHI-finity. So please check out the previous video if you're interested in that, or my upcoming video. And I hope that you appreciated just the simplicity of this drawing technique to draw the accurate dodecahedron. So thanks for joining me, and many blessings to you, and much love and appreciation. Keep on drawing, and I'd love to hear in the comments how this one was for you. As I mentioned, I have an apprenticeship that's 8-week. I have one starting up this coming June, this 2022. So check that out if you're interested in wanting to learn a lot of the different techniques that I work with. And also have a Patreon set up. And a new offering is that I'm starting to work with people one-on-one who have very specific interest in sacred geometry, and doing a lot of one-on-one mentoring to address those types of questions. And I already have a few people I'm working with at that, and those are going really great. So check that out on my website. I'll put all those links over in the description. So once again, have a happy weekend. Peace.